Welcome to tutorial 2. In this tutorial, we'll be creating and deploying smart contracts. Our goal will be to create a purchasing, a custom token, and a comments smart contract and deploy them to the blockchain. Smart contracts are essentially lines of code which control the execution of a transaction between blockchain accounts based on events. Smart contracts are regarded as self-executing and intended to avoid the need of intermediaries or third parties. We will use the Solidity programming language throughout these tutorials to program Ethereum blockchain-compatible smart contracts. Please refer to the documentation if any Solidity syntax used in this tutorial is unfamiliar. Solidity has influences from C++, Python, and JavaScript, and you'll see some of the similar syntax used in the following examples. In this series, we're going to build a simple blockchain-powered e-commerce marketplace, where buyers are limited to only purchase one of any item. We will start with creating a basic purchasing smart contract to record products, quantity, and buyers on the blockchain. What you want to begin with is to open up the contract template file. That's under contracts/purchasing-template.sol. A couple things to note about this project. A struct, like the one we have here, is a custom defined object type in Solidity, which can group together different types of variables. In this contract, we have a product details custom object. And this contains a bunch of variables defining the various attributes of the product. Things like the purchasers, the URL, the description, price, etc. Events are inheritable members of contracts. Here's the event that we're using. When you call them, they cause the arguments to be stored in the transactions log, which is a special data structure in the blockchain. We can access these events from a tool like BlockMason Link. To trigger an event, we use the emit keyword, followed by the event class. The product details are mapped to a product in the product list mapping object, which can be publicly accessed, and that's found here. The authority of the smart contract, which is the line right below that, here, will be the address which deploys the contract, i.e. the message sender, when deploying a contract using BlockMason Link. The Link default wallet is the deploying address and will thus be the contract's authority. Now moving on to some of the functions we need to complete. There's going to be 4 of them, and the functions are add product quantity, purchase product, and get purchasers. Let's take a look at add product. This is the most involved function out of the list, but it's still relatively quite simple. We just need to add our arguments to the corresponding product in the product list mapping. We complete the function by emitting the product event. That's going to look something like this. Here we have the product list and the emit event here. Next, let's look at the add product quantity. Here we want to add quantity to an existing product, so we'll first need to check that the product exists in the product list before cumulatively adding the quantity. We will use the require Solidity keyword to check for the requirement first. Once we've completed that, it's going to look something like this. Next, we need to take a look at the get purchasers function. Here we simply need to return the purchasers array for a particular product from the product list. That's going to look something like this. Finally, the last function we need to handle is the purchase product function. Here we need to do 2 things. First, we need to check if there's a product available for purchase, since each buyer is limited to one of any item for our example. We can simply check for the product quantity is greater than the length of the purchasers array. We will use the require Solidity keyword once again to check for this requirement first. That will look like this. And then we need to add the buyer to the purchasers array for the product once this requirement is met. And that will look like this. Those are all the functions we need to complete. You can see the completed smart contract code in contract/purchasing.sol if you want to verify that you've done everything correctly. Next, we're going to be tackling how you can deploy the purchasing smart contract using BlockMason Link. The process for connecting and interacting with external blockchains using Link is relatively straightforward using the Link project wizard. Let's take a look at what the process flow looks like. You begin by creating your smart contract in Link. You then label your public blockchains, followed by setting up your network connectors by identifying the network's public JSON RPC API endpoint. Then you deploy your smart contract onto the public blockchain, label your generated APIs, label your API consumer, and finally obtain your OAuth API authentication. This is the whole general flow of how Link interacts with blockchains. But now let's look at it from the application point of view. Let's now deploy the purchasing.sol smart contract to a public blockchain. In Link, we first want to click on the Create New button, which starts the new project wizard. Select Create New, and then copy and paste the purchasing.sol code into the source code field. Set the display name as purchasing, press save, and next. Use the default account. This is the Link default wallet we seeded with our test utility tokens for our specified blockchain as part of the setup. Under which network you'd like to use. When we're deciding which network we want to use, select Create New and name it based on the network you are using. Keep the block confirmations needed at 0 and the default EVM version. Press save and next. Under which connector would you like to use, select Create New. Enter in a connector display name and provide the appropriate network RPC URL. Take a look at the Link onboarding section on how to use public blockchains if you want to know more. Ensure that you're using the correct network and press save and next. Now we just need to label our deployment. Under Where is your contract deployed, select Create New. Call this deployment Purchasing Testnet Deployment. Since we don't have an existing contract deployment, leave the address field blank. Ensure the account is the default account, the contract is the purchasing contract, and the desired network. Then press Save and Next. Now we are ready to deploy our contract to the desired network. When asked, "Are you ready to perform the following deployment?" press Deploy, and you should get a Deployment in Progress indication icon. This might take a few seconds to complete. If deployed correctly, you will automatically proceed to the next step to set up your API. Do note that if you get an error related to insufficient gas fees, you need to seed your Link default wallet with the test utility token of your selected blockchain network. Refer to the Blockchain Network Token Setup section of Tutorial 1. Now that that's done, we label our purchasing contract API under Name. Call it Purchasing Testnet API. Also add in a human-readable display name. Ensure you are using the correct contract deployment. Press Save and Next. Now we label our Purchasing API consumer. This is usually the name of the app or service calling the API. For example, let us call the consumer e-commerce app. Ensure you are using the correct API and account. Press Save and Next. Lastly, your consumer needs to be authenticated with the Purchasing API. An OAuth 2.0 client secret is automatically generated. Ensure you are using the correct principal, consumer. Press Save, Next, and Finish. Once you hit Finish, you should end up back at the home page and see your purchasing code in the code editor, the API tab, and a gear icon which toggles the client ID and client secret auth credentials at the bottom of the page. Use these credentials to interact with your newly created APIs. Also, by clicking on the Code API toggle, you will see the full list of available API endpoints generated from the smart contract code. Also note that all calls to these API endpoints must be made asynchronously when using JavaScript. Congrats, you have successfully deployed your first smart contract to the blockchain. We are going to be following the same steps that we just completed to deploy a custom token which will be used under the hood in our e-commerce marketplace app. In Contracts, open up the basic token.sol. Note, this is a simplified contract adapted from the ERC20 standard. There are only a few customizations you need to do to this contract before deploying it. A couple of things you'll want to do is change the contract's name to your token name, set your custom token symbol, and then down in the constructor, customize the following lines. Add your wallet address to the treasury, and set your total supply. Your treasury wallet address goes here, but of course you can also use the message.sender if you want to use the default account. That's what it would look like with the default account. At this point, your custom token contract is ready to go. Follow the previous deployment steps in BlockMason link to deploy the custom token contract. The final smart contract we will deploy is for comments. With the full Solidity code in contracts/comments.sol. This contract is quite straightforward, using just a comment event emitter every time a comment is made about a product. Follow the previous deployment steps in BlockMason link to deploy the comment contract to your blockchain. Use the Blockchain Explorer to confirm that you have successfully deployed all your contracts. Congratulations! You have now successfully created and deployed multiple smart contracts. In the next tutorial, we will use our Link APIs and Link SDKs to interact with these contracts.